In this video, we want to look at how we can solve these inequalities. Okay, well, there's absolute value inequality where we have a less than and a greater than. There's an absolute value equation when we have the equal sign. Okay, so what I've done is I've gone to my graphic calculator. I asked my graphic calculator to graph for me the line y equals 5. Which is this horizontal line. And I've also asked it to graph y is equal to 2x plus 1 absolute value, which is that V shape that you see right there. Okay? Now, so if I'm asking when is 2x plus 1 equal to 5, I'm asking where do they meet? So I want to know precisely the x value at which they meet. And you can see there's two values at which they meet. They will be meeting at x equals 1, 2, and at x equals negative 1, 2, 3. Now you might say, well, how are you supposed to know that? Well, quite simply the following. What's inside of this absolute value bar could be 5 or negative 5. Because indeed, when we take its absolute value, we strip it of its sign. So that being the case, I'm going to take what's inside the absolute value bar, to 2x plus 1. I'm going to set it equal to 5. I'm also going to take what's inside the absolute value bar, 2x plus 1. I'm going to set it equal to negative 5. Solving this, 2x, you subtract 1, we get 2x equals 4. We get x equals 2. Solving this, subtract 1, we get 2x equals negative 6. Therefore, we got x equals negative 3, just what we knew it was to be. So, generally speaking then, when you're solving something of this variety, absolute value of x equals a, you simply take what's inside of there, x, and you set it equal to a, and you take what's inside of there and you set it equal to the opposite of a. And if there's other things attached to the absolute value, such as maybe 5 minus 6 times, well, you've got to isolate the absolute value. Okay? Now, let's look at this. Again, here's my two graphs. The 2x plus 1 absolute value, the V shape, the y equals 5. I want to know when is the V shape underneath? When is it less than the value of 5? Well, again, we know when it's equal, it's right there at negative 3. We know when it's over here, it's equal to 2. So the values of x for which that absolute value graph is underneath is obviously all these values of x right here. Okay, running from, not including, open circle. So we know that those values of x, okay, are all the x values, okay, that are in between 2 and negative 3. Now, a simple way of solving that is to take the absolute value of 2x plus 1, take it outside of that, compare it to 5, and compare it to the opposite of 5, okay? And then when we solve that, we subtract 1, we get 2x. We subtract 1 over here, we get 4. We subtract 1 over here, and we get negative 6. Okay? This I meant to be negative 3. I think you'll agree. Okay? And then, as you can see, dividing by 2, we get that, okay, the absolute value of 2x plus 1 is less than 5 for all the values of x between negative 3 and 2, which we could write as an interval, negative 3 to 2. Okay? So generally speaking, down here, if we have any absolute value of x less than some value a, then what we do, the cost of removing the absolute value bars is to compare it to a and compare it to the opposite of a in that sense. Okay? Now, one last. Let's take a look at absolute value of 2x plus 1 is greater than 5. Well, then again, greater than 5 would be when the V shape is above the y equals 5 line. The values of x for which that applies, which again, we know is going to be at here, and everything outward, all the x values greater than 2. That's all the x values that are greater than 2. Over here, again, the absolute value graph wants to be above the horizontal line, and that's going to occur for all the values to the left of -3, which is all the values of x less than -3. So we know what our answers are here. It's absolute, it's x is greater than 2 and x is less than -3. Now, how could we get that? Well, we simply can take this expression, 2x plus 1, and compare it to 5 and solve it quite simply. 2x is greater than 4, so x is greater than 2. And also take that expression, 2x plus 1, that's 2x plus 1, 2x plus 1, and compare it to the opposite of 5, -5, with the opposite comparison. So the cost of removing the absolute values is to get two comparison, one compared to the same value without the absolute value, the other compared to the opposite value with the opposite comparison, proceeding to solve. 2x is less than -6, x is less than 3, okay, which is the interval from -infinity to -3, not inclusive, in union with the interval from 2 out to infinity. So the generalized expression, absolute value of x is greater than a, is simply taking what's inside, whatever's inside. In this case, it was 2x plus 1, but generally, whatever's inside, and comparing it to a, and taking what's ever inside and comparing it to the opposite of that a value with the opposite comparison. Try to clean that up a little bit with the opposite comparison. So there are the three base rules there for absolute value equation, for absolute value inequalities with a less than, and absolute value inequalities with a greater than. If you use those, again, if it's anything tagged on to the absolute value, you've got to isolate that, okay? Remember also with your inequalities, your less than or greater than, anytime you're dividing by a negative, you're going to have to switch that sign, okay? So we might get a chance to look at a couple of those examples, but there's the explanation for how we generally tackle those problems, okay?